Hello, in today's class, we'll be considering gravitational field. Yes, that's our topic for today's class. And let us start by defining what the concept is. Gravitational field is the region around a body having a mass in which the gravitational force of that body can be experienced. One of the greatest scientists of all time did a very wonderful work on the concept of gravitational field, and he postulated a law called Newton's law of universal gravitation, and it states that the force of attraction between two bodies is proportional to the product of their masses and inversely proportional to the square of their distance apart. So let us consider the two bodies. Let's say this is the first body and this is the second body, and these bodies are separated by the distance r. So according to Newton's law of universal gravitation, it states that the force of attraction between these two bodies, let's call this, remember we said they have masses, m1 and m2. So the force of attraction between these two bodies is proportional to the product of their masses and inversely proportional to the square of the distance between them. And we said that the distance between them is r. Therefore, mathematically, we can say that the force of attraction, F, is proportional to the product of their masses, m1, m2, over, and inversely proportional to the square of their distance apart, so r squared. So if we cancel these proportionality sign and then involve equality sign, we will see that a proportionality constant will be introduced into the equation, and we have F is equal to K m1 m2 over r squared. In some cases, K could be G, could be anything you like. Is that okay? It could be S. So the most important thing is that we are going to substitute, or we are going to replace the proportionality sign with a particular constant called the proportionality constant, and in most cases we use K or G as the proportionality constant. Okay, now where m1 and m2 are the masses, and then like I said, K is the proportionality constant. And in most cases it is called the gravitational constant. Is that understood? So let us consider an example to illustrate what we have here. Okay, before we consider the example, K has a numerical value of 6.67 times 10 raised to the power minus 11 Newton meter squared kg minus 2. So this is the numerical value for K. So you have to commit this to art. Most times you might not be given, and sometimes you'll be given in a question. So if you're not given, just know that K or G, as the case may be, is equal to 6.67 times 10 raised to the power minus 11 newtons meter squared kg raised to the power minus 2. All right, let us consider an example to illustrate what we have. We said that two bodies having masses m1, which is equal to 100 kilogram and 90 kilogram respectively, are separated by a distance of 1 meter. Calculate the magnitude of the force of attraction between them. We are asked to take G to be equal to 6.70 times 10 to the power minus 11 newtons meter squared kg raised to the power minus 2. Remember, I said that G or K, as the case may be, is called the gravitational constant, and most times it has a numerical value of 6.67 times 10 raised to the power minus 11. So if you round it up, you can have it to be 6.70 times 10 raised to the power minus 11 newtons meter squared kg minus 2. So if you are not given in the exam or in a particular question, I would advise that you use 6.67 times 10 raised to the power minus 11 newtons meter squared kg minus 2. But if you're given, just use the value you're given, because your answers will depend on it. So let us solve what we have over here. The first thing we have to do is to state the given parameters. We have m1 to be equal to 100 kilogram. We have m2 to be equal to 90 kilogram. Okay, and we have the distance between them to be equal to 1 meters. All right, we asked to find the magnitude of force, and we said from the previous slide that F is equal to G m1 m2 all over r squared, and we have our G to be 6.70 times 10 to the power minus 11 times m1 is 100 times 90 all over r squared is equal to 1 squared. Therefore, the magnitude of force of attraction between these two bodies would give us an approximate value of 6.03 times 10 to the power minus 7, and because it is a force, the unit is Newton. So this is the magnitude of force of attraction between these two bodies, and that is how we solve for the force of attraction between them. You might be asked to find one of the masses or the distance between them, provided you are given the corresponding parameters. Okay, so for instance, if you're asked to find the distance between the two masses, all you just have to do is to make r the subject of the formula. For instance, remember that we have F to be equal to G m1 m2 over r squared. So if you're asked to find the distance between them, you have that you just have to cross multiply, and this will give us fr squared equals G m1 m2. Okay, and if you make r the subject of the formula, we have r squared to be equal to G m1 m2 all over F. Of course, we are looking for r, not r squared. Therefore, r is equal to the square root of G m1 m2 all over F. Okay, so this is the formula for calculating the distance between the two masses. For instance, if you are given one mass, you are given the distance, you are given the force, and of course, you know the gravitational constant. You can't find the value of the second mass. For instance, if you're asked to find one of the masses, we can still deduce from this relation that m1 will be equal to fr squared all over gm, such that if you cross multiply, you have, this is m2, if you cross multiply, you have, okay, m1 m2g equals fr squared. You can return this relation back to what we have over here by making f the subject of the formula, and if you do that, f is equal to m1 m2g all over r squared. So depending on the parameters given and what you're looking for, you can maneuver or change the formula to suit the particular problem you are asked to find. And this is where we'll wrap it up on these segments. In our next class, we will discuss the gravitational potential. So see you in the next class.